Okay, so Astro is a really performant HTML-first full-stack framework built on top of the most popular programming language in the world, supporting both established backend services and a long list of modern UI libraries. So, if that's the case, why would you even consider building your next project with a different framework? By the looks of it, Astro has it all and excels at everything.
From this day forth, you put your faith in me.
So let's find out if this is really the case and spend the next 10 minutes reviewing Astro's key features and main selling points. During this time, we'll start by building a static microblogging website, which, by the end of the video, will become a full-stack web app with a backend API and database support. The aim is to get a good understanding of the entire Astro ecosystem so that you'll feel confident enough to decide on your own if this tool is a good fit for your next project. You'll need an up-to-date version of Node, and then you can run this npm create astro command. We'll go through the wizard quickly and end up with this project structure. Quick side note, we are using the Node.js runtime, which is the de facto solution these days. However, other alternatives such as Dino or Bun are gaining traction thanks to an improved dev experience and better performance. We'll stick with Node in this video, but you can find official documentation outlining the use of Astro with Bun. Back to the project structure, the UI will be split into components, layouts contain templates where shared parts of the UI are defined, and the pages directory is where our app routes will live. Astro offers a wide range of configuration options, and all this can be easily managed in the Astro config file. Note the output static entry here. Based on this config, Astro knows how to bundle and prepare our app for production. The static option results in a static site that can be deployed to any static host. This is also known as SSG and is the default mode in Astro. We'll start with the default configuration and then move to a server or hybrid approach to employ Astro's SSR in the second part of the video. Let's open the default layout file where we can define a basic structure for our app. This is an Astro component which follows the single file component architecture. In other words, we'll write JS scripts separated by code fences, the HTML template, and the styling rules all in the same file. The layout component can receive a title and some details, which are then filled in the header. In the body, I'm defining shared header and footer components, and the slot special element where the actual page content will be displayed. Before moving to the rest of the implementation, let's quickly discuss styling. CSS rules are scoped by default but can easily be defined in the global scope. Sass can also be used if it is detected in the dependency list. Okay, back to our code, the footer and the header are both plain Astro components. Remember that Astro's default behavior is to compute these components on the server, render the HTML, and then send that static HTML to the browser. You can interact with the site via its usual HTML links and forms, but if we want to add in some actual client JavaScript interactivity, we need to follow a few extra steps. First, we'll install the Solid.js integration in our project. This is an easy process which makes a couple of changes to the dependencies and the Astro config file. I'm choosing Solid here because of its simplicity and performance, but Astro offers a wide range of other options. The second thing we'll do is to rewrite our header from an Astro component to a Solid component. Crash course in Solid components. They are plain JavaScript functions using signals to manage data, effects to react to data changes, and JSX for templating purposes. We can now add an on-click event listener for the right button. Now we should be able to jump into the browser, and whenever the button is clicked, the alert should pop up, right?
Wrong.
At this point, Astro is still generating static HTML on the server and then simply rendering it in the browser. For the button to become interactive, we need to tell Astro that the header component has to run code on the client and, as a result, to hydrate it. So, the final step of this process is to jump back into the layout component and add the client directive to our header. Let's take a step back and analyze this process in more detail. Before enabling hydration, Astro aggregated components on the server, generated static HTML based on those components, and then presented the static HTML in the browser. With hydration, on top of this existing process, once the static HTML reaches the browser, subsequent resources are requested from the server. First, we need the actual header code so that the client can regenerate the components on the front end and correctly attach event listeners. Second, of course, we need the actual Solid framework code. Our components are written in Solid and will most likely use internal Solid.js features. As a result, any used library will also become a client dependency that needs to be downloaded and executed before your app becomes interactive. You'll often hear that Astro is performant and efficient because of its island architecture. This is a fancy way of describing the process we already looked at. Whenever interactivity is needed on an otherwise static page, an island of interactivity is defined via the client directive, and then, instead of hydrating or re-executing the entire app on the front end, only the designated islands go through the hydration process to gain interactivity. Moving to the pages directory, Astro is using a file system router to handle user requests. So let's create an index.astro file which will map the root path request. In the template area, we'll use the layout created a minute ago, and then, in the body, we'll iterate over a list of saved blog posts. Don't worry, we'll get back to this implementation in a second. Then, let's create a contact.astro file to map the contact path, and, to make things a bit more interesting, an about.md file to map the about path. Markdown is commonly used to author text-heavy content, and Astro offers built-in support for it. So the process should be clear by now. You can map requests to files inside the pages directory. Easy enough. However, this can easily get out of hand once your app grows in size, so Astro offers content collections to alleviate some of that pain. Inside the content folder, I'm creating a blog directory where all our articles will be defined. These will be plain markdown files with some front matter data. Then, in a config file, we can export the blog collection and the type schema. Now, we can jump back into the index.astro file and get the post collection. We'll filter our draft entries, then iterate over the list and render links pointing to our post unique URLs. In order to handle these requests, we'll create a new directory under Pages and an Astro file capturing a dynamic route. Inside this file, I'm getting the unique URL from the Astro params object, and then I'm using it to retrieve the actual blog entry. All this information is then displayed in the DOM. It all seems straightforward, but you'll be greeted by this nice little error when you'll check out your app. So let's think about this issue for a moment. We are still building a static website, which means that the whole thing is analyzed and computed at build time. In other words, your production SSG site will contain a bunch of HTML files that can be served upon request. There is no mechanism in which new pages can be generated at runtime, so all pages have to be known when the app is built for production. Hopefully, you are not asking yourself, why bother with SSG? It's always more time and resource efficient to serve an existing HTML file than to compute it on the server for each incoming request. Okay, back to the error, we are presented with two main options. We either switch to SSR, or we define a getStaticPath function, which can be used at build time to understand your entire app structure. We'll look at SSR in a second, but for now, let's jump back into our blog post page, define the static path function, and compute an appropriate result based on our blog entries. Up until this point, we've seen how to build performance static apps, which can still enjoy JavaScript interactivity, handled through an efficient hydration process thanks to the islands architecture. However, most of the time, you'll be faced with more complex requirements in real-world projects. Most modern web apps communicate with databases, offer REST APIs, and various other server-side capabilities. Astro is the perfect fit for such scenarios as well. Let's first update the output mode to server in the Astro config file. Then, I'm going to set up a Turso SQLite instance to test some database scenarios. Quick FYI, Turso is a little yet powerful tool allowing you to persist and scale your data at the edge, all via great developer experience. I'm doing similar deep dives on various tech topics on this channel, and I'll tackle working with Turso soon, so please click the subscribe button if you're interested in more similar content. With the database in place, I'm creating a service file for our SQL queries, and now we can update our Astro code. I want users to be able to post their own content on the platform, so under Pages, I'll create a write.astro file, which simply loads a solid.js editor component. This component is using the client-only directive, so it will only be rendered in the browser. Then, in the editor, I'm defining an input and a text area, and I'm pointing them to signal entities. When the user clicks on the Save button, an async post request is sent to the API post endpoint. Next, let's create an Astro endpoint. Under Pages/API, we'll create a new .ts file. The Astro file-based router will still work as you'd expect, but in this case, instead of sending an HTML response to the client, we can actually send JSON. The data is retrieved from the request body and sent over to the Turso database. Finally, we'll go back to the index.astro file and replace the old collection call to a database call which fetches the user-created data. I strongly believe Astro is offering one of the best dev experiences out there, while also being a good fit for most types of web projects. Let me know your opinion in the comments, and until next time, thank you for watching.